we're going to take these resistors that are being applied to a 15-volt source, and we're going to calculate the total resistance. Total resistance is R sub T. We're going to take R sub 1 plus R sub 2 plus R sub 3, and adding those together, we wind up with 44 ohms. To find the circuit current, we need to take the current is equal to the 15 volts. Actually, this is V divided by R. 15 volts. We're going to divide that by 44 ohms. And using the calculator, we're going to calculate the current. Let's take a look. So on your calculator, turning it on, take 15 divided by 44, and you come up with 0.34. So the amount of current for this circuit, 0.34 amperes. We need that value. So to calculate the voltage drops then, we're going to take this particular value, going to use V is equal to IR. So in the case of the first one, we take 0.34 times the resistor of 10 ohms, and this comes up to 3.4 ohms. I'm going to write those right here. 0.34 volts. The next one is 12 ohms, so we're going to take our 15, we're going to take our current of 0.34, multiply that times our 12 ohms, and this is 4.08 volts. And our last one, which is on the 22 ohm resistor, I'm going to take 22 times the 0.34, and this will come 7.48 volts. Now, as we look at this then, we're going to have three different voltages, and we're going to take the sum of these voltages and call this our Kirchhoffs Voltage Law, which says that the sum of the voltages around a series circuit is equal to the source voltage. So in this case, we're going to say our V sub T is equal to V1 plus V2 plus V3. V1 V2 and V3. So let's add these up and see what we come up with. 3.4 volts plus 4.08 plus 7.48 is equal to 14.96. It's approximately is equal to our source. This is what you should pretty much get. Now, because we've got these different voltage drops, we're also going to have different kinds of polarities. Because this current is flowing around in this direction, the polarity of the voltage will be plus, which corresponds to the most positive part of the power supply. This one will also be plus and minus, and the last one will be plus and minus. So with regard to the voltage that's applied across all of these, we're going to have the same amount of current, but our voltage drops are going to have these polarities, plus, minus, and plus.